Okay, right now we're going to talk about parallel lines cut by a transversal. When we say transversal, we mean this line right here that's cutting across parallel lines. I don't have parallel lines right now because I first want to talk about just when two lines cross. We talked about that last week, and we know that this right here forms a linear pair. So this has to be 150. And it forms linear pairs all the way around, and we know that vertical angles are congruent as a result. So we get something that looks like this all the way around. Vertical angles are congruent, and anything next to each other is a linear pair. Well, now let's look at what happens if I have parallel lines. Well, what's a parallel line? Remember that a parallel line is just a line that is going in the exact same direction. If it were on a graph, these lines would have the exact same slope, and unless they're lying on top of each other, they're never going to touch ever. That's because they're going in the exact same direction. So all I did was copy this one, so we know that it's exactly the same line going in exactly the same direction. So let's think about what's going to happen then with this and how that relates to these angles right here. If this is the exact same line going in the exact same direction, this is a line right here. And what do we know about lines? Lines have a constant rate of change. So this one is not going to suddenly change direction here. This is going in the exact same direction. And this is going in the exact same direction. And that means that this line must be meeting this line at the exact same angle that it's meeting this line, because all these lines are still going in the exact same direction. And you can see that if I group these together. So all I've done is told this to keep these guys together. And if I were to slide this up and down, you can see that these angles are never going to change, and they'll always be the same with both of these because these lines are heading in the same direction. I could do the same thing, maybe it's a little easier for you to see if I were to just slide this guy up and down. If you think about it, these are going to be the same. Well, what does that mean? That means I have a nice little result here. This angle right here is going to be the same as the one that corresponds with it down here. And of course, that results in this being a linear pair, and these being vertical angles, and these being vertical angles, and the same reasoning all the way around here. But what do you see? Since this is essentially the same line as this, we've got all the same angles as we do up here. What results is that all corresponding angles are congruent, and that means all the ones that are in the same spot. So everything that corresponds is all going to be the same. So I've got that one, this one, these right here, and of course these right here. All the ones that are in exactly the same spot, bottom right, top right, top right, top left, bottom left, are all going to be congruent. All the corresponding angles will be congruent. There are also some other relationships between angles that are congruent. We're going to skip the vertical angles because we already know that. We're going to be talking about these parallel lines and how these relate to these. So we can also see that this interior angle, now the difference between interior and exterior. Interior, of course, means inside, so that means in between the two parallel lines. Exterior means outside, so we're talking about on the outside of the parallel lines. Whenever I say interior, that's interior. Exterior, I mean outside the parallel lines. So we'll also notice that the interior angles are congruent, but not on the same side. They're congruent on opposite sides. So we say that alternate, so the other side, alternate interior angles are congruent. So that means this guy will be congruent to, on the inside, the opposite one. So the alternate interior. This one will be congruent to this one, and this one will be congruent to this one. Alternate interior. So if you're on the inside, the guy on the opposite side is congruent. What about the exterior then? We're just talking about these guys that are on the outside. How do these on the outside compare to these on the outside? Well, it has a very similar relationship to the ones on the inside. Since they're all linear pairs, they're just going to be the opposite linear pair of each other, right? So I've got 30 degrees here, and on the other exterior, on the opposite side, I have 30 degrees again. I have 150 here. On the other exterior, on the opposite side, I have 150 again. So then we say alternate, opposite sides, alternate exterior angles are also congruent. Okay, so that means on the exterior, the outside, this guy is going to be congruent to the alternate exterior on the outside, the other side. And this exterior is going to be congruent to the other exterior on the other side, alternate. Alternate exterior angles are congruent. So as you can see, this results in some sort of zigzag pattern of congruencies here. If I were to start at the top and zigzag my way down, these guys are going to be congruent. 150 to 150 to 150 to 150. You're just going across, across, across. All of these guys are going to be congruent. And similarly in the other way, all these guys will be congruent across, across, across. So you kind of make this zigzag Z across everything, and I'm going to get a whole bunch of congruencies. That all results from the fact that all corresponding angles are congruent, all the ones that are in the same spot. And then alternate interior angles are congruent, the ones that are across from each other on the inside. And then alternate exterior angles are congruent, all the ones that are across from each other on the opposite side. Results in the zigzag, all these congruencies are true when I have parallel lines that are cut by a transversal. And if you ever see these little arrows on these lines like this, that means that they're parallel. So I have these parallel lines. If it's cut by a transversal, these things always happen. So just because I made 30 resulted in these other angles, but any angle here would have resulted in the same situation. If I were to put 40, then that would just mean that these are 140 and so on.